Hey kids, Flexing Teacher Weber here. I hope you're having a good day. Today we started looking at subtracting mixed numbers. And there's a lot of similarities between that and adding mixed numbers, but there's a couple things we need to look at. So what I'd like to do here is start with a word problem. I actually didn't do this word problem in class, but I thought I'd do it now. So it says on Saturday, after painting his daughter's room, Mr. Weber had 2 3/4 cans of paints left. On Sunday, he used 1 1/4 cans to finish the room. How much paint is left now? Model the correct statement and solve. So we always talk in class about reading the problem over multiple times and then looking for keywords. And the keyword here is how much paint is left now. And also using cans of paint. All these things indicate that this is a subtraction question. So you want to make sure you look out for keywords like how much is left, or if you're using something, indicates that something is being subtracted from the total. So whenever we have this kind of situation, we started off with 2 3/4 cans of paint, and we used 1 1/4. And just like when we were adding and subtracting fractions, we subtract the whole numbers. 2 minus 1 is 1. And then we subtract the fractions, and they have a common denominator. So 3 minus 1 is 2 over 4. And then 2 over 4 can be simplified by dividing the numerator and denominator by 2. And that gives you the fraction 1 1/2. So Mr. Weber has 1 1/2 cans of paint left. Period. So that's the topic we're studying today. We're studying subtracting mixed numbers. Now that's a very simple example, but its example illustrates words to look for when you're encountering a problem, and words like left and used indicate subtraction. So the topic we're studying today is subtracting mixed numbers, and we're going to focus just on ones that have the same denominator. So we did a question just like this one previously. We'll do another one now. So when you have questions that have the same denominator, 3 in this example, we have 3 7/8. Subtract 1 5/8. And what I want to do first is I want to do a little estimate of what the solution might be. So I'm going to put estimate up here. And whenever we're estimating, we want to round off our numbers to numbers that are really easy to do in our head. So the number 3 7/8, that's really close to 4. So I'm going to round that to 4. And 1 5/8 is actually really close to 1 1/2. But I'm going to make this a really simple estimate, I'm going to round it up to 2. So for our estimate, we have 4 take away 2 is 2. And that's going to be our estimate. Now, to get the exact answer with these mixed numbers, you have the same denominator 8, so all you need to do is 3 take away 1 is 2, and 7 take away 5 is 2 over 8. And then recognize that you can simplify this fraction by dividing the numerator and denominator by 2. And then you get the answer 2 and 1 over 4. And that is very similar to our estimate. Okay? So we estimate just to get an idea of what the exact answer might be so that we know if we're on the right track. And based on our estimate matching our exact answer, I think we are. Now that's a really, really basic example that has same denominator. I want to look at what the most challenging situation is. And that's where we have the same denominator where we have to do regrouping. Now I want you to think, we're going to look at this question. This question is going to be 4 and 3 over 8. Subtract 1 and 4 over 8. Okay, and I want to do a little estimate first, so I'm going to do the estimate over here. And I'm going to say that 4 3/8 is a little less than 4 1/2, right? So I'm going to say that that rounds off to 4 1/2. And then actually 1 4/8 is exactly 1 1/2. So I'm going to say we're going to round that to 1 1/2. And then for your estimate, well, you get 4 minus 1 is 3. And 1/2 minus 1/2 just goes away. So our estimate is going to be about 3. Now, here's where this one looks easy, but it's a little bit trickier. Check this out. I've got a 3 on top for my numerator and a 4 on the bottom. So we have to do 3 minus 4. And a lot of kids confuse this. Okay, they think, well, 3 minus 4, I'm just going to write this over here. They think these two are the same thing. 4 minus 3 and 3 minus 4. But they're not the same thing. 4 minus 3 is equal to positive 1. And 3 minus 4, or 3 negative 4, is equal to negative 1. So these are not the same thing. Now the situation we have here is we have 3 minus 4. So we have a 3 minus 4, and that's negative 1, but we're not going to get a negative fraction. Negative fractions do exist, but they don't exist practically, right? You can't have negative 1/8 pizzas of pizza. But they do exist in the math world, negative fractions, but we know we're not going to be getting a negative fraction because we already estimated that the answer is going to be somewhere around positive 3. So we can't, a lot of people say, oh, you can't do 3 minus 4, but we can do 3 minus 4. It's negative 1. But that's not the correct way to do this. So we're going to do something called borrowing and regrouping, and it's something we actually do when we do subtraction with whole numbers. Just over on the side here, I'm going to show you a typical example with whole numbers. With whole numbers, we might do something like this. 25 subtract 18. And I would say, you know what? I don't have enough ones to subtract 5 and 8, so I'm going to borrow a group of 10 from the 2, and this will become 15, and then 15 minus 8 is 7, and 1 minus 1 is 0. So that's something we do. It's the typical subtraction algorithm. We're going to do the same thing now with fractions. Watch this. We don't have enough fraction parts to subtract the bottom from the top. So what I'm going to do is I'm going to borrow 1 whole from the 4. And I'm going to make that 4 3, and I'm going to take that 1 whole on a ride to fraction land. And I'm going to add that 1 whole onto the fraction part 3 over 8. But I'm not going to write it as 1 whole. I want to add it onto the 3 over 8, so I'm going to write it as 8 over 8. So all I have done is taken that 1 whole from the 4, brought it over to the fraction area, and written that 1 whole as 8 over 8. Now what I can do is I can add up 3 over 8 and 8 over 8. And that equals 11 over 8. And now what I can do is I can subtract these two fraction parts, and I have a numerator that's larger than this denominator down here. So now I can subtract the parts. 3 take away 1 is 2. And 11 over 8 subtract 4 over 8 is 7 over 8. And that is really close to my estimate of 3. So that's how we borrow and regroup in subtracting of mixed numbers. I'm going to do one more. So we've got another question, 5 and 1/5 minus 4 and 4/5. And I'm going to do an estimate first. Okay, so 5 and 1/5 is really close to the whole number 5. So I'm going to write that as 5. And 4 and 4/5 is also really close to the whole number 5. So I'm going to do 5 take away 5. And my estimate is going to be something close to 0. Now, look at my fractions. Once again, on top I have a 1 take away 4. Now, I don't like when kids say they can't do that. That can't be done. It can be done. 1 take away 4 is negative 3. But we know that we're not going to be getting a negative fraction because our answer is going to be somewhere around 0. So we can do 1 minus 4, but what we are going to do is we're going to borrow from the whole number to make this fraction larger. So what I'll do is I'll borrow 1 whole from the 5, and I'll cross out that 5 and I'll make it 4. I'm going to take this 1 whole over here and add on the 1 whole, but it's not going to be written as 1 whole. I want to be able to add it on to 1 over 5. So I'm going to write that 1 whole as 5 over 5. And then I have the ability to add up these two fractions and have a fraction that's larger than that one. So 1 over 5 plus 5 over 5 is 6 over 5. And now I can subtract 6 over 5 minus 4 over 5. So we'll go and do that. 4 take away 4 is 0. And I don't really need to have the 0 there. And then 6 take away 4 is 2 over 5. And that's a fraction that is quite small and fairly close to our estimate. So you have 2 questions to do today. You have ML 257, number 5 and number 6. You'll have to do some basic subtraction and some borrowing and regrouping as well. I hope this video helps. That's all for now. Flexing Teacher Weber, out.